thanks for coming to this talk. I know there was one on PHP 7, and that has a good buzzword that's probably a little more pulling people in this talk. But I did have the buzzword Raspberry Pi, which is cool. But I'm not talking about that kind of Pi, not in this presentation. I don't really like Raspberry Pis, but I do like Raspberry Pis that are computers. So when I was thinking of an actual topic for this presentation, because everybody can build a cluster that runs a Drupal site, I wanted a more specific goal. And so my goal is, being somebody who works for a company that builds Fortune 500 websites using Drupal, I was wondering, can I run a Fortune 500 website from my basement using a cluster of Raspberry Pis? And also, a lot of people ask me this, especially if they've never seen the cluster, seen it perform. They ask me, why would you do that? We already have Amazon, we already have Azure, and all these other services. So I'll answer both of those questions. But I wanted an ambitious target for this presentation. I didn't want to be like, can you run Drupal? It's like, yes, of course. Can you run WordPress? Yeah, but can I actually run a decent website, and can I power it? So before I get into the demo and the software side of things, basically for me, this is more of a hardware story because when I was growing up, this was my bedroom when I was a kid. You can see, here I'll use my little laser pointer. You can see over here, this was actually my bed, and there was our ISDN modem. We actually had an ISDN line 128 kilobits into our house in like 97 or 96 or something. That was awesome. Everybody else had their 33.6 or slower. So anyway, my dad brought home a Gateway 2000 33 megahertz 486. Up until that time, I had used some Macs, and I did some graphic design, and I was just getting into video a tiny bit. My dad had a digital video camera, so I had that G3. But he brought home this old Gateway 2000. It was a decommissioned old server that he had, and he also brought home a giant Red Hat 6 book. And this isn't Enterprise Linux 6. This is Red Hat 6, like way in the old days before Enterprise Linux was a thing. And the book had a CD in the back that had Linux on it. So I installed it, and he said, you can do whatever you want with it. It's an old server. I don't care about it. So I put it on there. I got a file server running, and I was basically sitting around in the command line. First exposure to the command line, I thought it was kind of mysterious and cool, but didn't really do too much with it because I had a G3 that was like 90 times faster than it sitting right next to it. But it was fun to experiment. Another thing that I was doing around that time was I was helping some small businesses and some schools to get their first website running. So I helped, just up the street from me, the grade school I went to, I helped them install one of these. It's called a Whistle Interjet. And it was running FreeBSD4, and it was kind of like an internet server in a box. Like literally you get a box, you pull this thing out of it, and you plug it into your modem, you plug it into your network, and it runs a web server. That's all it did. So I thought that was pretty cool because instead of having this giant server thing or having a server that's hosted somewhere, you could just plug this thing in at your house, plug it in your workplace, and I helped some people do this, and this was literally their first website. So it was nice, but it was still kind of big and bulky, so it wasn't something you could stick in your pocket or in your wallet or anything like that. And in 2012, I got back into things. After that time, I had gotten a lot more into the software side of things, and I had been doing a lot of web development, but not really thinking about servers or anything. In 2012, the Raspberry Pi Foundation gave the world the Raspberry Pi, in this case, the Model 1B, or the One Model B. And it was really cool because not only was it a full Linux computer the size of a credit card, it's the same size as these that you see up here, but it also had these GPIO pins up here, which you could control using software. So you could do things like write a little script that would turn on a servo motor to turn something. So like in my childhood, I remembered movies like Back to the Future, where the first whole scene is this giant contraption that pours a cup of coffee and feeds the dog. Like in my head, I was like, whoa, that's reality. Like I could do that. Like you could do that in the 80s, but you had to be a wizard to do those kind of things. Nowadays, you still kind of have to be a wizard, but you can build those things with the Raspberry Pi. And so I got a couple of these. I got a couple of Arduinos or however you say that word. And I started getting out my soldering iron, which I hadn't gotten out for like 5 years. I started building circuits and putting things on a breadboard. It was really cool. So I also got this strange notion as the Raspberry Pi became a little more powerful, especially as it became super-de-duper tiny like this little Raspberry Pi Zero, which if you'd like one, I'm giving this one away after the presentation. I'll show you how to get that in a little bit. But it was amazing. It got so tiny, and it got even faster. And it had, this one has 512 megs of RAM on it. So it's decent enough, now I'm thinking in my head, to run a website, because the VPSs I use for some of my lower-end websites are just 512 megs. So I got this weird idea in my head, why not put Drupal on it? But I had a few issues. So here's a banana for scale, if you can't see this that well. So I had a few issues with it, though. One problem with just running a server on one Raspberry Pi is that you don't have any redundancy. You're not able to, if it goes down, you have to rebuild the entire Pi from scratch. And it's harder to back things up and switch back and forth. Another problem is the micro SD cards, these teeny tiny little cards that go in this slot. They're not all that reliable, especially compared to an enterprise class hard drive. So you have to worry about reliability issues. Another issue is that if I just have one of these running and the database goes down, which happens, anybody who's run a website for a long period of time knows databases just go away or have weird problems or get corrupt. So if that ever happened and you had a Fortune 500 website that your company is relying on, you don't have a backup, so I need that. Also, if you just have 512 megs of RAM and you're running a modern PHP application like Drupal, which is extremely bloated and heavyweight, you're going to run out of memory really quick. And then try to throw MySQL on top of that, it's really going to run out of RAM. So we can't just use one Raspberry Pi. So instead of that, we're going to use what's called a high availability infrastructure. And who here's familiar with the term high availability and what that entails? Okay, good. So this was labeled intermediate. I'm glad that you guys interpreted that correctly. But basically, the things it gives you are redundancy. So you have multiple servers doing the same thing. So if one goes down, you just switch across and you can swap out the Pis. Now, this hardware, to swap out a Pi, I have to unscrew things and move things around. But you could build a case for these Pis that lets you hot swap them. And some people have done that. In fact, there's a company, I don't have a picture of it, but there's a company that you can take Pi Zeros and they make a little board for them and you just stick them in and it networks them all together. It's really cool. So you have redundancy, the ability to hot swap, and in this infrastructure that I'll show you, it has a hot backup basically of the database. It has a master slave or master replica architecture. You can also do master-master or whatever you want to do. And the other nice thing is, since the resources are somewhat limited, you can separate concerns and have a really good PHP server and a really good database server instead of a mediocre everything server. And these things don't apply just to the Pis. They apply to any kind of server, any kind of infrastructure that you're building. So in 2014, I got the idea that I could build this cluster instead of just trying one Raspberry Pi. And that's when I put together the first version of this using Raspberry Pi 2s. And there's a big picture of it in case you can't see this. Luckily, we're in a small room, so you can kind of see this too. And of course, there's a banana for scale. But the cluster actually, when you look at the spec sheet on it, it actually is a decent cluster. It has 5 gigs of RAM total. It has, in aggregate, 6 gigahertz of processing power. And it has 80 gigs of super high-speed micro SD cards, meaning they're way, way slower than even a spinning hard drive. And it has a middling but decent enough if you are dealing with just a few, 10, 20 megabits of bandwidth. It has decent enough onboard networking. So you can also find, by the way, this presentation is not going to dive deep into everything, but if you go to pydramble.com, and there will be a link to that at the end too, I have setup instructions, parts lists, links to everything, videos, how to put it together, all that kind of stuff is there. So I'm not going to go deep into that kind of stuff in this presentation. But the infrastructure that I targeted, so initially I didn't target this. Initially I was going all for performance. So I actually had six Pis with 4 web servers, 1 database, and 1 balancer. That let me get a lot more requests per second because PHP is kind of the slowest thing on a Raspberry Pi as opposed to MySQL and some other things. Because PHP consumes, well, in Drupal 8, PHP consumes a lot of memory. Or if you're using Symfony or an application that requires a lot of structure. And it uses a lot of memory. But I kind of changed things up because I want to build an enterprise site, so I wanted more availability, and I didn't want to target performance as much. Plus, cutting off one Raspberry Pi saves like $50 total. So if you want to build your own one of these, it's a little cheaper. So this infrastructure is going to have an Nginx load balancer, and requests will come into it, and it will split them between two Nginx with PHP and Drupal 8 web servers. And for Drupal 8, there's a few different ways you can share files between servers, but I chose to use NFS just for simplicity. Of course, it kicked me in the butt last night when I was trying to get it to actually work with Raspbian Jessie. There was an issue with it, but don't have to get into that today. And then they are going to talk to one master database server with a replica. So this is a pretty standard, old school, high availability architecture. There's different ways you can do this. You could have two masters, so both of these web servers will write to both. You can do a lot of different things, but this is the one. There are many like it, but this is my own. But one thing that's a problem, if you have one Raspberry Pi, it's not that big a deal to install the software you need on it or configure all the configuration files. It's still nice to use something to do that for you, so you don't have to log in and do all the stuff by hand. But the problem that you have when you have multiple servers is you need to be able to wrangle them, to get them together and do the right things. And also, like for this cluster, if you were to come up here, please don't do this, and just like sit on it, break it, throw it against the wall or something, if I wanted to build another one, I want to make sure that I can rebuild it quickly. That's even better high availability because actually at home right now I have a Pi 2 cluster that's the exact same as this, and I could bring that one up if I ever needed to in about an hour or so because it has to compile PHP 7 since there's no package for Raspbian for it. So what I do to make sure that I can get that configuration on the Pis is I use software called Ansible. Who here has heard of Ansible, familiar with it? Okay, so most of you guys, that's good. So Ansible came along in 2012, and unlike some of the traditional configuration management systems, it was built more for the sysadmin, and I won't call them simple-minded because I'm more of one of those kind of people at heart. People who don't want to spend time deep in code. So you can put your infrastructure in code, but instead of having to write code and think in code like programmers do, it's just configuration in YAML files, and the whole world is moving to YAML. So it's nice that Ansible is ahead of that curve already. Ansible basically is what I call configuration management for humans. And another analogy that you could think of is these Raspberry Pis, when you first boot them, they're kind of like cows roaming on the plains. And Ansible will kind of pull them in and get them all moving in the right direction. If you want to get more into Ansible, I'll give you a very brief introduction to how it's working with these Pis in a minute. But if you want to get deeper into it, I actually wrote a book. It's not the book, but I wrote a book on Ansible called Ansible for DevOps. It gets into a lot of examples, and it's kind of it assumes that you've written shell scripts and you've dealt with servers before and you can log into them, but nothing more, if you want to start automating your infrastructure. So that's available all over the place. I'll have a link to it in the end of the presentation as well. But now I want to show you a little bit about how it actually performs and how it can actually host an enterprise Fortune 500 website. So the first thing I'm going to do, if I can, there we go, get out of here. I'm going to use Ansible. Right now I'm plugged into the Raspberry Pi cluster there. And earlier, if you look at the videos and the setup instructions, I set up IP addresses, static IP addresses for all the Pis. And that allows me to use Ansible and just tell it, these are the Pis, and these are what they do in my infrastructure, so I can control them easily. So if I go over to the Raspberry Pi Dramble project, which is on GitHub, if you want to get this ever, this is the inventory file, which basically tells Ansible, these are the servers I have. So first we have a balancer. This is a group balancer. And in the group, there's only one server. So this is the top server. And then there's two web servers. And these are their IP addresses. These could be host names too, but I don't want to deal with DNS because I hate DNS. When you're dealing with live demos, it's never a good thing. And then there's two database servers at the bottom. And I also have a couple extra little variables that are attached to each of these. So the second one is a slave, and the first one is a master. That helps it set things up when it builds the infrastructure. And there's also a group of these different servers called Drupal. So if I want to target the whole Drupal, I can. And by the way, Drupal, if you look online, there's an Urban Dictionary entry for it. That's not what the Drupal is. The Drupal is the Drupal bramble. Bramble is a cluster of raspberries, and it's a cluster of Raspberry Pis. Kind of adopted that, and so the Drupal is Drupal running on a bramble. So anyway, I can address the Drupal that way, or I can say like target all servers, and it will target everything in this inventory file. So that's cool because now, even if I didn't want to automate my entire infrastructure, I can use the Ansible command, and I'll pass it that inventory file, and I can run things like ping. This is a module. -m tells Ansible to use a module. I can use ping, and it's, oh, I forgot to give it a target. So I say Ansible Drupal. So I want to ping all the Drupal hosts, which is all the servers, and ping them. And it'll say I could connect to them successfully. I can also do cool things like I can see how much memory is available on each of the Pis by running the free command. So just using the Ansible command line itself, you can run commands on all the Pis. You can reboot them. You can do things like that. You can target different parts of your infrastructure. So already Ansible is pretty powerful. If you ever used a tool like Func, or there's a couple other ones that kind of wrangle your servers like that, it's useful there. But I also have playbooks that'll do things like deploy Drupal and deploy Redis and configure things. And you can put them all together, and then you have an entire infrastructure. So, and at the end of this, if you have questions, we might be able to have a little time to look at that or see some practical examples. But for now, I'll show you the site that's actually running on this server. If I go to pydramble.com, and note that if you go to pydramble.com, you're on the public internet, so you'll see the one that's running in my house right now, hopefully running in my house right now. But this one is running on this local infrastructure. And you'll notice when I loaded the page, you saw a couple LEDs blink here. So what this is doing is every time that there's a request to Nginx, I have a Python script that's running in the background, and it monitors the Nginx access log, which is written to on every request. I don't recommend that for performance, especially with a micro SD card, but to make the LEDs blink, I'll sacrifice performance. So every request to Nginx results in the light blinking. So you can see one request in Drupal 8 actually has a lot of Nginx requests. So Drupal 8's a little bit heavy, and it's using a bunch of different layers of caching, and that's why it's doing so many requests in the background. Plus, there's a lot of resources, the CSS and all that kind of stuff. But if I go to the command line and curl, I can just do pydramble.com, www. Then you'll notice that there's just one blink, because that's just finding the HTML page and not all the other resources that it's loading in.
So the top one, your Nginx, and then the
yeah,
it's just throwing the cache back at it.
Yeah. So and I'll show you how that's operating in just a second. So the top one's the balancer. These are two web servers, and MySQL obviously is not responding to web requests. And I haven't yet written a script to say like every query blink the light. I'll do that sometime. That'll really kill performance. Let's see. So, but it's, if I'm going around on the site, who here has ever used Drupal before? Okay, so a good number. Anyone Drupal 8? Okay, so only one person. Drupal 8 is actually a bit slower than 7 because 7 was I'd like to compare it kind of to WordPress in terms of the architecture. It was very procedural. It was very unstructured, and it had a lot of Drupalisms that made it faster, but also less flexible in its architecture. Like it was hard to swap parts out of it and things. Drupal 8 is built on Symfony, so it's a lot more swappable, testable, and depending on your brain, it's a lot easier to understand how things work. But it's also heavier weight, so it's things are a lot slower compared to Drupal 7, like a few times slower in certain scenarios. So clicking around on the site, you can see it's not too bad in the admin interface. If I go to the content page and add a new article, test, test. I'm not going to put this on the front page. Save it. It's a little slow. You know, if you're running on a really fast, nice, brand new server or something, you'll notice things are maybe twice as fast on the front end, but it's decently fast on the back end. And if your site doesn't have a whole lot of back end activity or logged in users, then you know this part of the experience doesn't matter as much. You still want to have a good experience on the back end, but it can be a little bit more sluggish. So I'm going to log out. And if I'm just on the front end of the site, things are actually pretty fast. So I can click around on the site, and you know things are loading pretty fast. And you'll notice after the first page load, so if I refresh, it's getting a cached copy from Nginx. But if I'm just clicking around in my browser, then it's still loading. So I guess it is still making a request. Yesterday, Chrome was not actually sending requests to the server, so it must have been using a local cache. But let's do a little benchmarking now. So just some basic ones. I'm going to use WRK. Who here has heard of WRK? Okay, so it's like Apache Bench, but I like it a little more. It's a little more intuitive, and it gives you results in a little more condensed format. So I'm going to say WRK-T4 for store threads, -C48 for concurrency, and -D5 for the duration of the test. www.pydramble.com. And when I load this, it's going to actually just hit the Nginx server on the top. So this is going to be a cached copy. And for most enterprise sites that I've worked on, 95 to 99% of requests are completely cached. Or if they're not cached, they'll be built into cache, and then the next request will be cached. So, you know, that's what I'm basing my assumptions for a Fortune 500 website on. It's mostly public, mostly cacheable. So we're going to see how much load just with the built-in LAN the Raspberry Pis can take. And you'll see that it's just knocking this one right out. And the LED blinking is probably using more CPU than some other things. But it can load over 1,000 requests per second, and that's a Drupal 8 site with a couple nodes on it. But that's right out of cache. And you'll see also that the transfer per second is 11.15 megabytes. That's actually telling me that my limitation right now is the network interface, because that's about what you get in a 100 megabit interface. So me tinkering around and hacking, I thought, well, you know, I could plug in a USB 3 cable and see if I could get more power. So I got a USB 3 network adapter. And even though the USB ports on here are USB 2, the USB 3 adapter works with them and will actually give you more bandwidth. So with the USB 3 adapter, I can actually get around 3,000, 3,100 requests per second cached. So in Drupal 8, since it has a really good caching system built in, and you can cache more content nowadays, most requests will be cached. And especially if you use a CDN or something like that, it doesn't even have to hit your servers. So we're pretty good on the cache front. Let's also test poking right through the cache. I want to test how Drupal's built-in cache, using the full Drupal. It has to bootstrap Drupal for each request. I want to see how that works. So in my Nginx configuration, I made it so that if I put no cache equals true, if I can spell, if I put this, then it's going to bust through Nginx's cache copy and then just hit the Drupal sites. So if I run this, you'll see that it's actually hitting all the servers, and you'll see that there's little breaks and things while it's kind of processing things. And the request per second goes way down from 1,000 to, let's try it again, because I'm going to give it a fighting chance. I always run my benchmarks 4 or 5 times, not in this presentation, but then I give an average. But that's pretty decent, 33 requests per second. That's requiring a full bootstrap of Drupal, which is a few megabytes of PHP that it's loading in and evaluating and everything. So it does have op cache running and all that kind of stuff, but it's respectable if you've developed in Drupal or Joomla or WordPress or things like that. They're kind of heavyweight. You know, if you do a custom app or something in PHP, it's not going to use that much resources.
And you're using a fast CGI, so you get a little more control over your memory and threads and stuff.
Exactly, yeah. So, and that's another point is, you know, a lot of people use Apache with mod PHP, and things get wishy-washy and start falling apart, and you don't get as much consistent performance, especially with an app like Drupal. So that's respectable. Now, the last test I want to do is actually log into Drupal and see how many requests per second I can get as a logged-in user. So for this, I'm actually going to use Apache Bench because it lets me pass through a cookie. And for Drupal, if I have a cookie with my session ID, I can actually pass that in and get logged in performance. So I'm going to do AB. I'll only do 200 requests just because I don't want you guys here until midnight. -C10. And then there's the session ID and the value. So this is going to load the page just like me sitting here if I were on the home page refreshing it. So you can see it takes a little longer when I am refreshing the page manually. So I'm going to see how it performs if you have just logged in traffic. That was really weird. And you'll see that you can even see the intervals there for the balancer. It's sitting there waiting sometimes. When the light's green, that means the balancer's just sitting there waiting. And where's error? Wait a second. Oh, here we go. So this was 11.62 requests per second. So, if you're dealing with cached traffic, cacheable traffic, which most enterprise-y websites deal with if it's a public-facing site that people aren't logging into to do stuff, or if you just use external web services to do things like commenting and all that, you can deal with entirely cached traffic, and it's going to handle that fine. If it's not cached, if you don't have Varnish or Nginx or a CDN running in front of it, then you're going to have to deal with something like Drupal's built-in cache, which is a lot slower. And then if you're dealing with a lot of logged-in traffic, it's going to not scale quite as well. But it's still respectable. 11 requests per second it's good enough for a lot of sites. I've seen a lot of sites with less traffic than that think that they're all high and mighty. But one of the keys of this talk is being a high availability architecture. And I'm a risky kind of person. That's why I was doing this demo for the first time last night. And I thought, what's a better demonstration than actually unplugging the master database server and seeing what happens here. So right now the site's loading fine. And let's say that some junior system administrator comes in and trips over your power cable and completely takes out your master database server. Normally that'd be a really sad thing. So right now alarms would be going off. People would be getting paged. People's salaries would be getting reduced quite dramatically. And you can see that it's loading. It's like, what happened to the database server? In a few seconds, it'll show an error message. And some people want to have an automated failover in this state. And that's an option. I could have built that in. But generally, if there's a problem like this, I want to see what's going on and be able to say manually, OK, it's time to fail over. Because failing over to another database server means a lot of work later. And if you can avoid it, you avoid a lot of reports, you avoid a lot of paperwork, and you also avoid a lot of work cleaning things back up afterwards. So right now the site's down. That's not a good thing. Luckily, Ansible to the rescue, I have a playbook that simply is going to switch the two servers in their roles and tell Drupal to point at the slave, which will be the new master. So if I say Ansible playbook, I'll show you this playbook in a second while it's running. Inventory. But I want to get this working really quick because the site's down right now. Playbooks, Drupal, MySQL, failover. So this playbook is first going to work on this bottom server, and I think I have it, it turns the LED red, meaning it's working on it. It's going to set it as the master, as the new master, and it's also going to turn off the slave mode. So you can see some of the things it's doing right now. And then after that, it's going to tell the two web servers to update their Drupal settings to point to the new master. So it's restarting MySQL on that server, getting all the configuration in. And now it's going to talk to the two web servers, turn them red. They're being worked on. And now the site should be back up. So now it's pointing at the slave. Master's offline still. Hooray. That's great. So that playbook, though, it's really simple. And this is the power of using Ansible, is doing things like this. Like I just did this in like half an hour last night between thinking of like, oh, that'd be a fun thing to demo, and then actually doing it. So all I need to do is tell it, target the slave database. There are better ways to do this, but I was, again, hacking this together last night. But target the database slave server, and it's loading some variables. And then this whole thing is just to tell it to turn the LED red on it. And I actually have, there's some helper scripts that I use, so Ansible, inventory. So I have a script on here that I can use to play with the LEDs. I can change colors and do fades and fun things like that. So when you're clustering, it's always fun to play around with things like that. Oh, that server's unreachable. I was like, oh no, I failed. So anyway, it's turning on the LED, and then it's telling it, instead of having this be the slave, tell it this is going to be the master. Then it runs this MySQL role, which does all the configuration. If you use Ansible, there's roles, thousands and thousands of roles out there to control any aspect of software. And there's modules built into Ansible to work with any kind of infrastructure, including Raspberry Pis. So it's pre-built and does everything for me. And then it runs stop slave and reset slave all, and then at the end of it, it'll restart MySQL, and that server will be happy. And then the next part of this playbook will run on the web servers, and all it does, so it does the LED stuff, and it sets a variable, and then it's just going to update the settings.php to point at the slave instead of the master. And then that'll be that. So that's once you get things described to Ansible, doing things like this is really easy. And if you're on a quote-unquote real infrastructure, you wouldn't have things like setting LEDs. So this playbook would become a lot shorter and simpler. It would only be like 50 lines to fail over to another database server. The other cool thing you could do at this point is it interacts with PagerDuty and with notification systems in Slack. So you could have the script also notify people in Slack that the database was failed over. And it could also set up something in PagerDuty to set up a notification system, things like that. Ansible is really powerful and flexible. So let's get back over to the presentation and go over some of the results. How are we doing in terms of running a Fortune 500 website on it? First of all, I want to go over, so I said at the beginning I work on some of these Fortune 500 websites, so I have a little bit of background on this. Generally, a lot of people say we want 100% uptime. We're focusing on getting 100% or 99.99959s. But really, in the real world, you're never going to hit 100%. So it's an impossible goal. Just running a computer 24/7, at some point it's going to have some downtime or unreachability. In Google's book, Site Reliability Engineering, which just came out, was just published a few weeks ago. It's a really good read for anybody interested in like DevOps. They even say 100% is the wrong reliability target for basically everything, pacemakers and anti-lock brakes being exceptions. Probably also space shuttles and things, but we know that it's not perfect there either. In general, for any software service or system, 100% is not the right reliability target because no user can tell the difference between a system being 100% and 99.999% available. If you're at home, every night when I'm at home, I'm watching Netflix or doing whatever, and it doesn't load for a few seconds, we're conditioned to know that things aren't going to be perfect, so targeting 100% is not only impossible, it's impractical. And Google Compute Engine, which a lot of the internet runs on, targets 99.95, so why would we go anything above that? We want more, but we can target lower, and that gives us some flexibility to do things like unplug our master database server in front of everybody. So another thing is the page loads per second. So I was looking at some stats for the backend servers for some of these Fortune 500 websites that I've worked on, and none of them on the backend, I'm talking like the biggest sites in the world will use a CDN like Akamai or Cloudflare or something Fastly in front of it to make sure that it can handle huge surges in load. And if you're going to run a site like that on a Raspberry Pi cluster, just like if you're running in Amazon, you would have a CDN to help with that load distribution. But the backends never get more than 1,000 requests per second, give or take. So on that aspect, I think we'll do okay. And then power consumption is another important statistic, especially if you're going to have a whole data center. If you're going to have thousands of these Pis running an entire company's operations, you want to make sure that they're not wasting a bunch of energy for the amount of performance they're giving you. So we have a target here A modern Core i7 or Xeon chip is going to give about 0.5 gigaflops per watt of computing performance. So for uptime, I've been running this cluster. Right now it's just running on one Raspberry Pi at home. I have the old Pi 2 cluster decommissioned right now. I had to steal some parts off of it. But I've been running it at home, and with the exception of 2 times when I had to move my network infrastructure around because I had remodeling, it's been up almost 100%. It's been 99.94, 95, 96. For the past month, it's been 99.96. So I think we're okay there. I cheat a little bit now. Originally, I didn't use it, but now I use Cloudflare in front of it. But that's how most Fortune 500 websites do it. So I figure I can too, and I'm not cheating too bad. For performance, like I said, if I use the gigabit adapter, I can get 3,000 requests per second. Now, of course, if you are running it in your basement like I am, and you're in a city like St. Louis that doesn't have fiber, then you're going to be limited to 7 megabits of uplink. So you're never going to see this much throughput in real-world usage if you're running it in your basement. But if I were running this at one of the hosting centers downtown, I could be hitting 3,000 requests per second. If I have logged-in users and people who are kind of bypassing cache all the time, obviously it's not going to be as good, but it's still decent. But as a point of comparison, and I actually have scripts in the repository for this project that will deploy the exact same infrastructure configuration to 5 DigitalOcean droplets or 5 VMs running on your local computer, so you can compare for yourself. My MacBook Air right here, which is actually 3 years old, is 6 times faster than that. And the DigitalOcean droplets are about 10 times faster. Of course, when you're talking about the DigitalOcean droplets, those are separate servers and sometimes could be on separate hardware. And they're running on SSDs with the latest Xeon processors and all that kind of stuff. So it's kind of an unfair comparison when you're talking about a $35 credit card size computer with a heat sink the size of a dime, basically. So in terms of power, though, the Pis actually, if they're running idle, they barely sip any power. I actually have one of those little battery pack chargers that's about the size of this guy. And it will run this entire cluster for about 12 hours. And if I'll show you something later, but it can run Raspberry Pis for a very long period of time, which is nice. But there's a problem in that when you're trying to get a lot of performance, so let's say you have high load on these servers, they actually don't give you as good budget in terms of performance per watt as something like an i7 or an i5 or even an i3 or Celeron. The best comparison would be something like a Pentium 4 processor or like a G3 if you're looking at the Power series. It's in terms of raw computing performance, not that close, but it's pretty decent. And it's getting better every year. This was like 0.04 when it was the Raspberry Pi B1. So we're getting better. The ARM chips are getting faster. So there are a lot of caveats to running on this kind of infrastructure. One thing is for myself, I'm running it in my basement, so I have it plugged into UPS, which because of the Pi's power sipping, it'll actually run it for 6 to 8 hours. But you have to deal with redundancy in power, you have to deal with their bandwidth, you have to deal with all these different things. So, most people choose to host with a hosting company instead of on Raspberry Pis on premise because the hosting company deals with redundant bandwidth and redundant power, fire suppression, security, all those things. If you're really running a Fortune 500 website, do you want to be responsible for all that with a Raspberry Pi, a couple Raspberry Pis sitting on your desk somewhere that somebody who's cleaning up after you could just take it off? You wouldn't want that to happen. So there are some trade-offs, of course, but I think you'll see that it's possible. It's something that you could do. Use Raspberry Pis to run enterprise infrastructure. So recently, the Raspberry Pi Zero came out. That was a few months ago. And they've been hard to come by, but luckily, I live in St. Louis. And St. Louis is a big enough city to get cool stuff, but it's a small enough city that all the tech nerds don't come and steal all the good stuff. So I was fortunate to get a lot of Pi Zeros. And so I say go small or go home. I built the exact same infrastructure using Pi Zeros. And sadly, the performance is way, way worse. So you probably wouldn't want to run a Fortune 500 website on here. But the cool thing was I configured it all so that this was running inside of an iPhone box, like a small iPhone box, with a little USB power pack that was routed to all these. And it used Wi-Fi instead of wired networking just to save a lot of space in the wiring. With that, I could get about 1/10 of the performance of this stack. But it was cool because I could have a redundant high availability infrastructure in a box the size of an iPhone, basically, a little taller, of course. But anyway, so that was a cool thing I did. And I also have performance benchmarks and all that on that website that I mentioned. And since I found an extra one time when I was at Micro Center, I'm going to be giving this one away. So a few things that I learned. How am I on time, by the way? I never even... Oh, sweet. I have plenty of time. We could talk even after this. So a few of the lessons I've learned. I actually have a blog post on my site with kind of these spelled out in more detail. But one thing is, how many people here have components in their infrastructure that they manage or pipelines that they use for deploying their application or anything that's not 100% automated? So what I will say to you is every one of those things is something that can save you hours and hours, hundreds of hours, maybe thousands of hours of time. And again, Google's Site Reliability Engineering book, if you don't have it and you do anything related to DevOps or sysadmin or infrastructure, it's a really good read. Obviously, your problems are not Google scale, but they have a lot of good lessons learned in there. And one of them is, if automation runs regularly and successfully enough, the result is a reduced mean time to repair for common faults. You can then spend your time on other tasks, achieving increased developer velocity because you don't have to spend time preventing problems or cleaning up after it. And just like you saw here, since I have everything automated, if I want to fail over, I just run that playbook, or I could even have it automatically run. That saves me a lot of time. Instead of logging into the slave and trying to figure out where the configuration is, remembering the MySQL command to stop slave and all that kind of stuff, I just run the playbook. It's not a big deal. And then when I want to bring it back to the other configuration, all I have to do is run the original configuration in Ansible, which is already set up, in which, not for this infrastructure, but for some of the other real-world infrastructure I run, I have it run continuously every day. So every day it makes sure that that configuration is back in line with what I set it up to be. So if you automate things, you save yourself countless hours, and you also save yourself countless levels of stress. So that was the main lesson. But also, especially when I'm benchmarking things, don't ever change more than one thing at a time, especially if it's, like I've seen these performance posts where somebody's like, oh, I changed like TCP no delay and send file and this and Nginx all at the same time, and they're like, and it's way faster. It's like, so which one of those things actually helped? Because I just changed those three and it wasn't way faster. So every time that you want to make a change, especially if it's MySQL or Nginx, PHP, that kind of thing, change it in isolation. Make sure you have a repeatable result. Every benchmark I've ever run, I do it at least 4 times. I discard the first result and average the rest of them. A lot of times I'll do more tests than that, or I'll have an automated script that runs it maybe 20 or 30 times. That way you know if there's network flakiness that affects it, that kind of stuff. One of the funniest things is almost every time I publish any benchmarks anywhere, the first thing they say is, well, you didn't run that more than once. So you know that things get cached, and it's like, never mind. You know. So Hacker News and Reddit are 2 of the most awesome and worst places on the internet. So another thing that is important to remember is that networks are never reliable. So I mentioned earlier that I don't use DNS for these live demos because I've had weird issues in the past. You'll also have issues if you use like Google DNS and then you're on a different network that blocks Google DNS. I've had demos where the DNS provider I'm using or the setup I'm using gets overridden by the router at that network. So I've also learned turn off Wi-Fi and switch just to this. If you're hosting your Raspberry Pi Dramble cluster at home, you'll have little issues like most consumer routers aren't fast enough to be able to provide the bandwidth to run a real website. So I bought a nice router for my house, my home internet connection. So never consider networks to be reliable. Build your infrastructure so it can heal itself, so that it has multiple routes to it, those kind of things, and you'll be in a much better situation. So kind of coming back to the question I had at the beginning of this presentation, most of the sites that I actually run in the real world, they're running on the cloud. So I use DigitalOcean. Some people that I work with use Amazon. Some people use Azure and all these other services. But it's been interesting. The server that I've had running at home, usually this cluster, but when I take it on road shows, I switch back to OnePy. It's been reliable. It's been fast enough for me. And for a lot of the sites that I build, if it's a lot of cached traffic, it's perfectly adequate. So I'm actually going to be this year at some point moving a few more of my personal sites over to my home infrastructure just to save a few bucks a month on droplets that I don't need to run. The other cool thing about it is, the Raspberry Pi is a computing platform with a great community and a lot of things like hats that you can plug in on top to do cool stuff. So like I did these LEDs. I've done a few home automation projects with temperature and HVAC. Since I have a Nest, I can control the API and do things like turn on certain zones in the house when I need to. There's a lot of cool stuff you can do. And this whole Internet of Things thing, there's a lot of stupid things that are done, but there's also a lot of potential there. And people like us can kind of guide the world towards the good and cool things instead of my fridge can talk to my washer now. Nobody needs that. So getting the Pi in 2012 and these Pis, I actually just got a new soldering iron. Like I'm excited. It's a fun hobby and passion to be able to do real world electronics work that integrates with the software that I write. It's not just bits on some cloud thing somewhere. It's running here in front of me, and I can make little LEDs blink when I get web requests. That's cool. So I guess the question for you is, where will you go from here? I know a lot of people have a Raspberry Pi sitting in the drawer somewhere. I'd encourage you to try new things with it, run your application on it, see how it runs. Maybe set up a cluster for Jenkins or something so you can do continuous deployments in-house on your servers. Things like that are pretty cool. So I think that's all, and here's some resources. If you want to win this Pi Zero, by the way, go to AnsibleForDevOps.com and subscribe to my Ansible for DevOps newsletter. You knew it couldn't be free, especially after people are selling these for like $7 online, getting them big markups. But anyway, yeah, sign up for the newsletter, and I'll pick somebody who's signed up to that newsletter at random. And unfortunately, it might not be somebody in this room, because I told the subscribers to the list that they could sign up too. But anyway, I'll give this out sometime later this week to give people a chance to subscribe and mail it off to wherever you are. But that's all. Yeah. So any questions? I know there's a lot of things I wanted to get into, and I didn't know how deep I wanted to get into Ansible or how deep I wanted to get into Raspberry Pi or soldering. But any questions or other projects? Yeah.
How do you think this thing, the rack, is going to be scaled? So if you want to twice the power of this original cluster, can you assume you can add 5 more servers and expect the same performance, or you have a double design?
So I did do some testing with that because was it you that asked me earlier how many Pis I have at home, or was it you? Somebody asked me earlier. You did? Oh, somebody was like, how many Pis do I have? I actually have 27 or 28 Pis at my house, and I scaled it up to use 5 web servers instead of 2, and I got pretty much a linear increase in the number of visitors I could hit. Of course, cached, it's the same. It's limited by bandwidth, but because Drupal is a very heavyweight application, I tuned the web servers to have just enough PHP requests piped through them so that the CPU wouldn't overload and so that it wouldn't start swapping. Swapping with a micro SD card is about the worst possible thing you could ever imagine. It gets really slow. So adding web server webheads actually does give a linear performance increase, and that would probably go up. I tested with 5. I would imagine you could get 10 or 20 web servers running before the overhead of the network would start doing anything significant. Yeah.
Have you tried using USB 3 flash drives instead of micro SD?
I actually haven't. That was one thing I did. I actually have an Envoy, one of those SSD, USB 3 SSDs, where I adapted the because in my MacBook Air it's old, so it had a 128 gig drive, and it's like nobody can live with that nowadays. So I bought the 512 gig, but I took that 128, put it into the external drive, and on my MacBook Air I can get 900 megabytes per second write and like 1,200 megabytes per second read, which is crazy. Like, remember that G3 in the early post? I remember benchmarking, and I was like, man, 30 megabytes per second. This thing is fast. I can do video editing. Now it's like...
I built a portable video library in a hollowed-out book for my dad.
Using a Pi?
Using a Pi 3 running Kodi, and I attached a 2 terabyte laptop drive to a USB adapter.
Is it an SSD or spinning?
It was a spinning drive.
No, 2 terabytes would be expensive SSD.
For something that we use once in a while, but it worked very well.
Yeah. Yeah, I actually did benchmark it on the Pi, and it only gets like 100 or like 80 megabytes per second. I don't remember what it was. It was pretty weak, but it was a lot faster than the micro SD. And I actually do have benchmarks. I'm not on Wi-Fi, so I can't show them to you. But I do have benchmarks on PyDramble.com of that SSD compared to the micro SD and a couple other things. Like I think I tried a little, I don't have it with me, a little flash drive, USB 2 flash drive. And the random write was actually super fast. So if you boot off of one of those, which you can do on a Pi, you gotta kind of hack things to do that. It is a lot faster, but for the purposes of this demo, I was gonna do that, but it's like, then you have this, and then the little things hanging off the back. It just starts getting to be a mess. And I don't have that much space in my cool little nuclear football box there.
That's what I was wondering about the flash drives, because you can get some pretty small ones.
Yeah. Some of the new ones are good, but what I found is they actually don't. The funny thing is, I think a lot of those flash drives are basically, they take the micro SD card and they like put a USB interface on it instead of the micro SD, because I was measuring the performance of the SanDisk Ultra, the SanDisk Fit, and Samsung has a couple. I measured like 5 or 6 different ones, and they were all identical, like exactly identical to the micro SD card. So like the SanDisk Ultra USB 3 drive is the same speed as the SanDisk Ultra micro SD card for random access. I don't care about the sustained read and write. Who cares about that? That's for people that take videos and stuff.
Do you have enough 3s to try it, like where you'll be doing that at some point?
Maybe, yeah. The thing is, like, Raspberry Pi needs to slow down with their releases, because I was just getting into the 2, and then the 3 came out kind of out of the blue. What I'm really hoping, like, if they come out with another thing that doesn't have USB 3 or some faster I/O interface, then I'm just going to skip whatever the next one is. Because the 3, I was hoping the performance would be way better and PHP would run way faster, but it's kind of middling. It's maybe 20% faster, but I don't use the Wi-Fi, so I don't care about that.
I was going to suggest using the Wi-Fi with NFS.
Yeah, well, I tried that. Wi-Fi on the Pis is pretty slow, and then you also have, like, at least here at conferences, you have interference issues that I've tried to deal with, and I never found a way to really get through them. So you end up with a lot less throughput and inconsistency. So like if you just run ping continuously, it'll ping at like 2 milliseconds, then 380 milliseconds, then 200 milliseconds, and it's like you can't have a cluster like this running a MySQL database on a separate server with that kind of latency, because web requests all of a sudden take 5 seconds instead of half a second. It's interesting because, like I said, networks are never reliable. I've had that happen with some lower cost internet providers. I'll have servers in the same data center that take 20 or 30 milliseconds to talk to each other. With DigitalOcean and with Amazon and some of the other ones, it's usually 1 or 2 milliseconds. But even there, if you sit there and monitor it for days, you'll notice there are periods when all of a sudden your servers, which are normally communicating instantly, take like 200 milliseconds just to ping each other. And MySQL is really slow, and you're like, what's going on? And it's somebody on the network is saturating things and causing drop packets. Networks are not reliable. So build your own, and you don't have to worry about it. Any other questions? Nope. All right. Well, thanks for coming. It was fun.